stream. And then let me hop back over here and let me reshare my windows because I think that it may have got booted. Let me just redo this and then we'll be ready to go. I want to share this one and this one. Okay, share. Okay, I think we're ready. Let me see. I think the stream is going. Let me close this out. Ali Oxenfree, the audio is showing there. Hello, hello. Okay, that audio looks good. Okay, let me check the chat really quickly and see what it's looking like. Okay. Yes, okay, so this is like one of the questions that I wanted to address. So that's one of the things. So the question was when is our first exam? So the first exam it'll open up this Wednesday. And basically it'll be over chapters R1 and 2, right? We did all of chapter 1, all of chapter 2, and we did 2 sections in chapter R. It'll open up on Wednesday and it'll be due this Sunday at midnight going into Monday, right? You get unlimited attempts at all the assignments, and you can actually submit assignments past the due date, but after the due date, there's a 10% late penalty. Okay, so the main thing, you just gotta get it submitted to wherever you want it to be in Blackboard. Thank you. Okay, let me check the chat. The exam should take you 40 minutes, something like it should take you about 40 to 50 minutes, and it'll probably take you a little bit longer than that. Like when I set it up, it said it said estimated time was about 50 minutes, and it'll probably take a little bit longer than that. So I don't know how many questions. It was kind of designed to take you a certain amount of time, but you get unlimited attempts, unlimited time. You just need to get it submitted. That's the main thing. I will still be updating the grade book and stuff like that. But yeah. Okay, so we finally got kind of rocking and rolling today. We don't have our little bit of music. We don't really listen to the music. It's just, it was. I don't know. I kind of got to work on my little setup because the stuff works, but it's kind of like overrunning my computer. So, my computer kind of can't keep up. But that's neither here nor there. Let me see. Only announcement is just exam 1 should be opening up this Wednesday. It'll be due this Sunday. Unlimited attempts. It's set to take your highest score. Yeah, and it'll be over all of chapter 1, all of chapter 2. So we'll be done with chapter 2 by like Wednesday, and then like I think we did 2 sections in chapter R. Next week when we get started, the pace is going to slow down. Instead of doing 2 sections a day, we'll be doing 1 section a day, and it should pretty much be 1 section a day until the end. Let me see. Check the chat one more time. Okay, chat looks good. So I'm actually just going to hop over to Pearson. Let me see. It did change there. Okay. Yeah. So my audio. Yeah, I'm just not going to worry about that right now because that's not even connected. Yeah. Let me do my speaker output. I'm just going to do, oh damn, I have to do that. That's so irritating. Let me see. Okay, so my input, first it looks like it's connected. Let me check. And see, yeah, this was the trouble that I was having. It was like locking up on me when I was trying to do what I needed to do. Let me let the student in there. Okay, that looks good. I'm gonna let him in. Let me see if I can get this working so I can hear. Okay, is this connected? I'm gonna give it a few. See, yeah, it's still doing that thing. So we might be without audio today because it's too much for the system. So I'm gonna have to go without the audio for today. You have to just use the chat because I just can't get it working. Okay. Let me see. So that's showing this. Okay, yeah, that's what we're gonna have to do today. Let's see. Oh, now you want to show? It's too late. Let's see. Okay, yeah, we can talk about this. So this question, I knew that was gonna happen. That's okay. Let's see. Yeah, all my stuff started. It's okay. You're in here. It's totally okay. Because, like, I'm kind of having a little bit of technical issues as well. As long as you're in here, once you get into the Zoom, you get credit for attendance. Okay. So, this is like a review question from, like, college algebra. Let's see if I can. Yeah, no worries. So express this log as a difference of logs, right? We have the log of a quotient. So from college algebra, the log of the quotient is the same as the difference of the logs. So log of V, it can't be B, it can't be, only one that it could be, it should be C. The log of the quotient becomes the log of the top minus the log of the bottom, right? So we're gonna go with C. That's from college algebra. Okay, so we're gonna have to redo all this stuff. All right, let me just close this out and go back here. Go to week 4 and make sure it's not open in another window because that's the trouble that we're having. Let's close this one out too. Week 4, this one. Let's try this again. Open this up. We're gonna hop. Let me make sure it's showing here. It looks good. V over T, okay. Let's do full screen. How do I show my screens? Share. Okay, and I want to share this one. There we go. Share the two. Okay, and let me make sure that it's showing here. All right, let's try this again. All right, again, just computer's acting up, totally acting up today. We must be in Mercury retrograde. Okay, so the log of the quotient becomes a difference of the log, so it has to be either B or C. B is not correct because it's the properties applied incorrectly there, so it has to be B. The log of the top minus the log of the bottom. Let's go with that one. Okay. And yeah, now we're grooving. From college algebra, the log of the product becomes the sum of the logs, and we're also doing a power rule. So we can write this. Hey, this is going to be a pain to write out. 9 times the log. So 9 times the log of x, log base b of x, okay, plus 9 times the log base b of y plus the log of base b of z. Okay. Okay. So again, if anything is not clear, feel free to either type in the chat. We don't have the luxury of unmuting ourselves today. That was just too much for the system today. So we're just going to rely solely on the chat for today. We can't, the audio is just too much right now. Differentiate. So this is coming from section 1.6. Let me see if there's a simple way. So we would have to use, I think we should do this one. We're going to have to use several rules at once. So I'm going to get a copy of this, and then we're going to go from there. All right, so let's go paper. Let me get myself some line paper. Let me take some notes first, and then we'll hop over to the tablet. So this is week 4, and I'm kind of watching the clock. I think about 6:35. Well, 7:15. We'll go to about 6:50. I want to try to hop to the next section. Week 4. This is day 7. 2.3 derivatives of log functions. Okay, derivative of logs. Okay. This is question number 3. This comes from section 1.6, question 41. Differentiate. Okay. We got f of x equals, we got this x to the minus 1 plus 7 under x. All right, let's hop over to the tablet. See if that's working. Okay. Yeah, I think we're okay. So we could use the quotient rule low D high minus high D low. Okay. So if we wanted to find f prime, so this would be the quotient rule. Low D high minus high D low over low low. So low, which is this, so it's the bottom, times d by dx times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay. So then if we evaluate this, this derivative here, the derivative of x is 1, so that just goes to 1. Let's see. So then the next part, so let me see, we're going to have this x to the minus 1 plus 7 is going to persist minus x times, so that derivative, it's going to be minus x to the minus 2, and then that's it there, right? And we'll make those adjustments over x to the minus 1 plus 7 squared, okay? Let me see. So this x should turn this x into a minus 1. Double negative makes those positive. So we just have 1 over x there. Okay. So it looks like we're going to have, I'm going to kind of keep working here. It looks like we have x to the minus 1 plus 7 plus x to the minus 1 all over x to the minus 1 plus 7 squared, right? So then basically 2 over x plus 7. Let me see. So I just want to see how they write their final answer. I'm going to hop back over to Pearson. I just want to see how they write their final answer, and we're going to match it just for the sake of time. I'm going to click on View an Example. I want to just go to the end. So they are using the quotient rule. I just want to get to the end. Okay, I'll let the student in momentarily. Let me get past this question. So let me see, right here. This is where we are. So then it should be 2 times that. So then they factored out, they multiply by, they use from college algebra, clearing out the fractions by multiplying the top and the bottom by the LCD of the fractions. Okay, that's fine. Let's do that. And then we'll get something that looks kind of like, what's the difference? They factored out, oh, they expanded. Oh my goodness. Okay, let's see if we can get there. Let me let the student in. Ugh. Let's go like this. We are working here. And this is the student. Okay, that's fine. All right. So let's hop back to the tablet and compare. Or let's see if we can get it to something similar, right? So I definitely saw this stage in the View an Example. So then that gives us 2x to the minus 1 plus 7 over x. So I guess if they expanded this, right? They expanded it to get rid of the negative exponents. So x to the minus 1 times x to the minus 1 should be x to the minus 2, right? So that's going to be x to the minus 2 plus 14x to the minus 1 plus 49, right? So then to clear out those negative exponents, we're going to multiply the top and the bottom by the LCD of all the denominators. Least common denominator, least common multiple of the denominators. Actually, yeah, I mean, it's not the least common, yeah, least common multiple, yeah. So anyway, in this case, it's going to be, we're going to multiply the top and the bottom by x squared. So we're going to multiply by 1 in the form of x squared over x squared. Let me give myself a little bit of space. So we're multiplying by 1 in the form of x squared over x squared, right? So when we distribute this x squared into all the terms, let's see if we can catch those changes. So on top, x squared or 2 minus 1 ends up being x to the power of 1. So 2x plus 7x squared over, on bottom, that's what, 1 plus 14x plus 49x squared. It looks like we can factor. Let me see the top. We can factor out an x. I don't know if that helps us or not. I'm going to leave the top as 7x squared plus 2x. Even though we can factor out an x, I'm not going to. But on bottom, it looks like it factors into 7x plus 1 quantity squared. Okay, I'm going to go with this. This looks similar to what they had as far as the final answer. So we're going to go with this style. Let me, let's check back on Pearson. I want to look at theirs one more time. We'll have one more question. View an example. That one was a little bit much. My computer's still trying to slow down on me. We're just going to do the best we can today because it is totally acting up. It's hanging in there, though. I don't want no food. I'm good on all that. Let's see. X squared. Okay, so they wrote it. They did factor that out. Okay. Okay. So let's submit our answer. I'm going to factor out the x from the top. So we get a result. We get the following result. On top, we have x times 7x plus 2. Okay. Hopefully we haven't made any mistakes. On bottom, we have 7x plus 1 quantity squared. Okay. We're going to go with that. Man, look at God. Okay. I'm just going to go to the next question. It's intense. I'm not going to lie. Like, because that takes patience. You got to slow it down. And we haven't even gotten into the stuff from today. I don't want to keep taking derivatives right now. I want to do this one, but we're kind of short on time. So I want to kind of go on to the next one. I want to try to find something from 2-3, a few examples from 2-3. This is 2-2. Just the recap from 2-2 was that the derivative of e is itself. So this is just like chain rule and the sum and addition rules, but it's mainly chain rules a couple of times, right? I just want to get to something from 2.3. Differentiate. Okay, so log. Okay, so let me take some notes here and let's introduce 2.3. So this is question number 8 from this section. 2.3, question number 1. I'm going to say differentiate. Okay. We have this f of x equals 9 times the natural log of x. Okay, let's hop over to the tablet. Make sure it's showing. My stream looks weak. My signal looks kind of weak. I don't know why. Okay, I'm going to have to let it be. So now, the derivative of log, right? Let me see. So the derivative d by dx of the natural log of x is going to be 1 over x. The derivative, or d by dx, say u was some other function, and we said like the natural log of u. This is going to be u prime over u, right? It's just the derivative of x is 1, so that's why in the previous example the numerator is 1. But really we're saying dx over x, or u prime over u, right? So that's natural log. The inside derivative divided by the original function. Okay. So for our example, if we have f of x equals 9 times the natural log of x, then f prime is going to be 9 times 1 over x. So basically it's going to be 9 over x. Okay. Okay, hopefully that was okay. Let's let's try a few more. So this should be 9 over x. Okay. Let me see if I can do this without writing them. Okay, here we either need to use the quotient rule or rewrite it so that we can use the product rule. So I'm going to have to write this one out because this one has some details there. This is question number 9. Comes from section 2.3, question number 9 from the back of that section. We're asked to differentiate. Okay. We have y equals the natural log of x over x to the power of 8. Okay, let's hop over to the tablet here. Okay. So I think I'm just going to do the quotient rule. So then dy by dx, so that's going to be the bottom, the low-d high business. So bottom, which is this guy, times the derivative, or d by dx of the top, minus the top times the derivative of the bottom all over the bottom squared. Okay, that's the quotient rule. So then on top, we're going to have the x to the 8 persists. The derivative of natural log of x is going to be 1 over x minus natural log of x times the derivative of x to the power of 8 is going to be 8x to the power of 7 over x to the power of 16. Okay. Notice all the terms have at least what, x to the power of 7. Actually, this x turns this into a 7 because you got x to the 8 divided by x, which gives us x to the 7. We can factor out x to the 7 from both terms on top. So let me write that in another line. I was going to try to do it on top, but okay, so if we factor out the x to the 7, the first term looks like it leaves us with a 1. The second term leaves us with minus this 8 natural log of x. Okay. We can rewrite that, but we're going to go with this for now. Because we can write that as a natural log of x to the power of 8, but over x to the power of 16. So then when we cancel, this is going to disappear. 16 minus 7 is what, 9. So this should turn into a 9. Okay. So then at this stage we have 1 minus 8 log x over x to the power of 9. Let me put this in a box. And I want to compare it to the view and example. I just want to see how they submitted their final result, and we're going to get ours to match. Okay. So we're going to hop back over to Pearson. I'm just going to go to the question help or view an example momentarily, and I want to just see the end result. Continue. Okay. The final one, let me see. Yeah, that's what we got, right? 1 minus something, they left it like that. Okay, that's promising. So then we're just going to type what we got. So let's see, the top is going to be 1 minus 8 natural log of x. The bottom is x to the power of 9. All right, let me see the chat. Okay, so again, you just have to do your best. My recommendation, do the best, do what you can on your own. I know you guys had a group me going, so definitely rely on a group me. Link up with some of your classmates. You also, the tutors are included in your tuition. I would definitely link up with the tutors and make use of the Ask My Instructors. If I don't respond to your email before the next class, just ask me during class time. Like, just get my attention and we can talk about things during class. That's why I moved to asynchronous, because sometimes the technology messes up. So I'm really just using class time for practice. You know, but I pre-record the lectures, and so all that stuff should be available. And then we can use class time to work over anything. Yeah, we can do this one. I think I don't need to write this one though. So if we're doing a chain rule, so the derivative of log is basically going to be u prime over u, right? So the derivative of the inside function divided by the inside function, right? So in this case, the derivative of the inside function is going to be 16x minus 9, and then over the inside function, 8x squared minus 9x plus 1, okay? So again, the derivative of natural log is u prime over u, okay? Hopefully that made sense. Let me see my time. So we're at 6:38. Let's keep going. This is the same as x to the fifth minus 12x to the minus 1. Let me see, if we did u prime over u, so that's going to be x to the fifth is going to become 5x to the power of 4. That was 12x to the minus 1, so that's going to become plus 12x to the minus 2. Okay, I should have put that all inside of a fraction. I don't know if this is going to work. Oh, it did work. Awesome. Okay. Let me think about it. Okay. Over the original. So I'm going to rewrite the original in the following way. It's going to be x to the power of 5 minus 12x to the power of negative 1. And then I think last time to clear out those, so if we have x squared on bottom and x to the power of 1 on bottom, if we distribute, I'm going to distribute an x squared into the top and the bottom. So then what's going to happen is this guy is going to become x to the 6. This x squared here, this x to the negative 2 is going to be gone. This is going to become x to the 7. This is going to become just x right here. Okay. That's about what I get. I'm going to go with it. Okay. So if I need to write out those details, let me know. I can go back and write them out. I just kind of thought out loud in this one. Okay. Find the equation of the line tangent to this graph at x equals 4. So basically, they're saying if we want the equation of the line tangent to the graph at when x is 4, so a line, we need a point and a slope. So basically, to find the slope of the tangent line, that's the derivative, right? So let's take some notes here. We can do this one. I know we need to kind of move on to the next section. Oof. All right. So this is question number 12. This comes from 2-3. That's not a 3. 2-3-21. It says find the equation of the line tangent to the graph. We have f of x equals the natural log of x to the power of 5 at x equals 4. Okay, let's hop over to the tablet. All right, so we're here. Let's see. Let me rewrite this so it looks neater. To the graph, delete, and graph. Okay. So first, let's find the derivative, right? So if we're going to do f prime, we can use the chain rule. So the 5 comes down, the inside persists. We subtract 1 from the exponent. We're going to say times the derivative of the inside function. So the derivative of natural log is going to be 1 over x. So I'm going to write it as basically divided by x. So that's the derivative. Okay. So we want the slope of the tangent line when x is 4. We basically plug in the 4 into the derivative. That'll give us our slope. So then f prime, here, let's do this. So the slope of our line is going to be f prime of 4. F prime of 4, and that's going to be, let's see, it looks like we need to get some decimals or something. We're going to have 5 times the natural log of 4 to the power of 4 over 4. That's a lot of 4s. Okay. We'll get a number there. We'll get something. I'll come back and find that number. So we have a slope. So then we need a point. So then let's say, okay, when x is 4. So let's look at when x is 4, what's our corresponding y? So that's going to be the natural log of 4 to the power of 5. And we get an answer there too. So I'm going to use my calculator. I try not to round. Let me see. So we have our x, we have our y. Let's solve for b. I'm trying not to round it to the end. So if we're going to use y equals mx plus b, our y value, I'm just going to leave it exact for right now. Hopefully that's, you can write out the decimal. Just take it a long ways out, write out the long decimal. The slope we got was this, 5 natural log of 4 to the power of 4 over 4. I'm just trying to keep it exact until the end. Our x was 4 in that case, so those two cancel. Plus b, right? So if we wanted to solve for b, notice that this cancels this. If we subtract that from both sides, we're going to get, I was kind of hoping that we could simplify it some. Long story short, b should be equal to the natural log of 4 to the power of 5 minus 5 natural log of 4 to the power of 4, right? So let's just put this in the calculator, and I think we can actually, I'm going to use this in my calculator to go ahead and type in the final answer. So I'm going to hop back over to Pearson. And before I do all that, do not round. See right here, this is why I was keeping it exact. It says do not round into the final answer, then round to 2 decimal places as needed, right? Okay, so that's why I was trying not to round into the very end. So y equals our slope. So let me break out my calculator. The handoff is actually throwing me off a little bit from Apple. How Apple does like handoff, it is kind of throwing me off a little bit, but it's okay. I just got to slow down and be patient and like work around it. Okay, so I'm just working in my calculator. I know I'm not showing it. So our slope, our m, we got that 5 natural log of 4 to the 4 over 4. So I'm going to crunch that number. 5 times the natural log of 4, that quantity to the power of 4. And then we're going to say, let me insert another set of parentheses. So I'm going to put one here and this. And we're going to say all of that divided by 4. So the slope that I get, if I round the 2 decimal places, I get 4.62. So we get 4.62. Okay, I'll let him in just a moment. Let me check my attendance. I think it's this one. Hopefully, so let me do it. And I think he already got attendance credit. I think he probably just got booted out or something. Okay. Let me hop back to my calculator. I think it's this one. That looks good. Okay. I'm going to let him in. Okay. So we got 4.62 for our slope. 4.62. Come on. 4.62x. And then the y-intercept that we got. So I need to crunch that number. So I'm going to say parentheses, the natural log of 4, quantity to the power of 5. I'm going to say minus that answer. Minus the previous answer. And so the b I get is 0.503, which rounds to just 0.5. Okay, so then I'm going to say plus 0.5, okay? All right, let's just go with it. We'll fix it if it's not right. Hmm. Let's see, what can we do? Type your answer and slope intercept. Do not round, then round to 2 decimal places. Let me see. Natural log of 4 to the power of 5 minus. Okay. I see what I did wrong. Okay, so I need to type out, instead of saying minus the answer, that's where I messed up. Let's back up and let me just type what we actually wrote down. So I'm going to say natural log of 4 to the power of 5 minus 5 times the natural log of 4, the net quantity to the power of 4. Because when we said minus the answer, there was an extra term in there that we were not supposed to factor in. Okay. So my y-intercept, I get negative 13.35. Okay, negative 13.35. So minus 13.35. Yeah. So we didn't have the luxury of just using an answer. It was basically a calculator stroke error there. If we get 15, we got about 25 minutes. So yeah, I would imagine. I mean, you should have questions like, but if you're, I had to kind of trust you and your judgment, and that you're making your way through it. I'm actually going to hop over to. I want to go to the next section and try to use the rest of the time to work on the next section. So let me get out of this and go here. Go back to the assignments. This is week 4, and we want to work on section 2.4. Open this up. Let's hop over to this, and let's show that at home for people. Where is it? Okay, here, let's do this. Like this, and then like this. Let's try it again. Let's try this, properties. That's not the right one. Here it is. Okay. Okay, that looks okay. We're gonna hop back over here, make that full screen. And I think I gotta fix my windows. That looks good. Let's do it like this. Let's do a new share. QuickTime looks like it's still sharing. And we want to share this one. Share the two. Okay. I think we're back. It looks like things are clicking properly. Let me go ahead and start my notes. So this comes from, and so I think I went on and made all the notes for the semester. I think I did make those available. So you should be able to access them on Blackboard. So like all the stuff you see me writing, it should be a log of it in Blackboard at this point. It should be for this class. So I think I did that last week. So this comes from, this is week 4. This is week 4, still day 7, which is today. This is 2.4 applications growth model. So doing 2.4 applications growth models. Also, these questions that we're doing in class, we don't have to do these questions during class. Like, I really kind of have it set up for class time to be a Q&A. So I encourage you to like ask questions during class. Like that's why I pre-record the lectures, so that I expect you to watch those lectures on your own time, and then we can take class time to work through problem sets. The reason I'm going through the homework though, because it takes a lot of encouraging to get students to like speak up during class. So I just fill it in with the homework, but we can work on anything. We don't have to do these specific questions. Um, I'm going to jump to something that's coming from section 2.4. So I'm going to skip this one for right now. I'm just going to go until I see 2.4. Because all this other stuff is like a review. Come on. I'm going to let that be for now. Gonna let it be. All right, let's start here. Find the general form of f if f prime Application growth models. Find the general form of f prime if find the general form of f if f prime is this. Okay, -3 times the original. Okay, so this is question what, number 10? Number 10. This comes from section 2.4, question number 1. I'm going to say find the general form of f if f prime equals -3 times the original. Okay, so then let's hop over here like this. Okay, so I kind of mentioned this during the lecture. Like, it took me a while for it to dawn on me. Then I realized that we got -3 times the original. So that's an indicator that this might come from an exponential function. So the general form of an exponential takes on the form, let me see, we're going to be using, it's like PERT, right? I think we can say, let's see, f of x equals, hold on, I'm trying to do it, because like I have a different way I want to articulate it, and I'm trying to match. Let me see. P not, okay, let me do this first. I'm gonna do what I'm seeing in my mind and then adjust. So normally I'll do it like, it'll be something like we can do a of t equals a naught e to the, more than likely this will be negative kt, right? So then we could do, to adjust for hours, we could say something like f of x some initial amount. What do they call their initial? Like p? I think they call their initial p. It's just a label. P e to the negative kx, right? Trying to think if there's anything else. So it should take on some form like this, right? Okay. So I want to say from here, I want to say our k looks like it will be 3. Let me think about it. If k is 3, p, what could p be? P would be 1. General form of this if f prime is this. I'm going to view an example. Because like, it looks like k should be like 3. Because, okay, let me show you what I'm thinking. Or let me try to share what I'm thinking, right? Say this is the general form. This f of x equals p e to the negative kx, right? Where p is just some initial amount, right? So then say we were to take the derivative there, like, and here, let's do this color because this is just my thoughts. So say we were to take the derivative, right? So p is just some number, it's just a constant. So the derivative of e is itself, so this would be p, let me think about it. This times the derivative of that plus this times the derivative of that, okay. So p e to the negative kx times, so the derivative of e is itself times the derivative of the exponent. The derivative of the exponent would be the negative k, right? So then notice how this is negative k times the original. So then that means that, long story short, our k needs to be 3, right? So then if we let k be 3, when we go to take the derivative, we'll get the desired result that we want. And we could probably let p be like 1, but p just needs is a constant. I think we would need more information to find the exact value of p. So usually when that happens, you can let p be 1. But what I'm going to do, I'm going to hop over to Pearson and see what they say before I submit an answer. So if I go to question help and view an example, let's see, f prime, if and only if, yeah, c, so they use c and I had like p, that's fine, where c is some constant. I kind of want to just jump to the end, okay? So again, the K, the rate is right there in front. You see it right there for the K. So let's get to the end. Therefore, any solution is going to be, yeah. So they didn't put anything for, so, but then you'll see. So we're going to do the same thing. We got the same result. We said let K, in our case, we said let K be 3. Let me see. Yeah. So we're going to do CE to the negative 3x. Okay, let's do that. Let's see, CE to the power of negative 3x. Okay. But yeah, like I'm trying to think of how to articulate that. The main thing is that I started with the general form of an exponential. Um, I'm used to seeing it as like PERT, but PERT is like in the form of like money when we have a principal and something like that. So then instead of the P, we kind of talk through the adjustments and the changes. Let's try another one. Let's see what comes up next, and let's just kind of do another one. Find the general form. So again, we have 6 times the original, right? You know what? I don't even think there's really much to do there other than say that was our K. So we said 6. We said CE to the power of 6t in this case, 6t, because it's not x, because it's by dt instead of dx, so that's why I use t. Okay, so we're kind of like working backwards there. I know that's a little intense. Let's try another one. Between these years, the number of applications for patients grew by about 3.8% per year. So that means n prime equals 0.038 times the original. Find a function that satisfies this equation. Let's go ahead and do that because that's kind of a repeat of what we were just doing. So we have 0.038 times the original. So then the original could be grew by this. Wait a minute. We might be able to solve for c in this case. Okay, assume that t equals 0. Okay, so let's write what we got before, right? So if we do the same thing we got before, we got something like CE to the to the power of 0.038t, right? But they give us, I don't know. It's nobody else is here. It's just me. I got a notification saying my internet is unstable. I'm like, I don't know what to do with that. But they gave us more information here, so we can actually solve for C. It says that when the time is 0, that corresponds to 2006. So when t is 0, that constant. C, it looks like C would be 2006. Let's see. Wait, when approximately 4,500 patients' applications were received. So when t is 0, we had a total of 454,000. So it looks like C is 454,000. All right, because that's the result initially. So we're gonna put the 454. 1, 2, 3. Maybe we don't need the comma. Let me try it with the comma, see what happens. Okay. So what I did there, I just repeated what we did in the previous 2 examples, but instead of leaving the C, they gave us the initial conditions. So when time was 0, the answer was 454,000. So if you let t be 0, e to the power of 0 is 1. So then we get C equals the 454,000. So then that's why I did that. If I need to write that out, let me know and I will. Hopefully that made sense. I think if you go to the view and example, they'll have it already written out for you, what we literally just did. The number of patients, so then once we have the function, it should be easy peasy from there. The number of patient applications in 2021 will be, so if 0 is 2026, 10 years would be 2016, 20 years would be 2026. So I think that's what, 15 years later, so t is 15. So then we basically let t be 15 and use a calculator to crunch the number. Okay, I'm just gonna do that off to the side. Reload and refresh. Okay, so I'm gonna do my 454,000, 1, 2, 3, times e to the power of 0.038 times 15, because it's been 15 years later. Okay, I'm gonna hit enter. round to the nearest whole number. The nearest whole number is a 3, so I get 802,793. 802,793. Let me see. The number of patients in 2021 with that model should be this. Okay. So all I did, I took the function that we just found and I let t be 15, put it in my calculator, and I rounded to the nearest whole number. Okay. I don't want to keep it for no more than about 5 minutes. The rate of change of the number of patients in 2021. The rate of change, round to the nearest whole number. Per year. Oh, the K? Are they asking for the derivative? Estimate the rate of change in 2021. I think they just want the derivative. Let me go to view an example. I want to get down to part C, so I'm going to just keep going. Okay, n prime, yeah. So we were already given the derivative. It says that the derivative was our rate times the original, right? So we just found that number, so we can take whatever number we got and say times the rate, and that'll give us the result. Okay, so we would say this 802,793 times 0.038. Okay, so I'm going to say that answer times 0.038, 3506. There's whole number 3506. 3506. Rate of change in the number of patients per year. So patients per year, applications per year. Yeah, okay. All right, let me see. Okay, I feel like that's enough. Let's do one more. We'll do one more and we'll call it a day. Okay, I'm not going to write all the details. I'm just going to kind of find the answers here. So this is question number 13. Question number 13. This comes from 2.4.13. I don't know what the BE stands for. 2.4 question 13 BE. In 2004, an art collector paid 56,437,000 for a painting. The same painting is sold, wow, 25,000 in 1950. Okay. Find a growth rate. So for part A, it asks us to find the exponential growth rate. Okay, so this was like working backwards. We had an exponential growth model. They kind of did it weird. Like they're essentially doing the same thing, but they kind of like switched, instead of, they switched the location of the starting amount and the final amount because they're kind of working backwards. I think I'm just going to use like our original formula and just kind of adjust because we're still working backwards. So I'm still going to use the original stuff, but I'm just going to adjust. And I'm still taking notes. Find the experimental growth rate K. So I'm going to say find K to 3 decimal places. That's not a K. Find K and determine the exponential growth function for which the painting's value is in dollars. So, okay, so basically 3 decimal places determine the growth rate. I think they want the value. So basically, instead of find K, I'm just going to say find V of T, find the original, right? Okay, let's kind of hop over to the tablet. And I'm going to just kind of do this one the way I see. So let me think about it. So if we're going to do, like in general, V of T is going to be, so we had some C times e to the, now normally it would be KT, and I'm going to I'm going to leave it as kt, right? And then, so it should be the case that v prime of t should be k times v of t, okay? So that's just like some background information. So do we don't have the rate. Let me see. In 24, they paid this, but in 50, they paid that. So we have two ordered pairs, right? So let's write these out. Okay. So I'm going to let 2004 be year 0. So I'm going to let t equals 0 correspond to, or that's going to be the year 2004, right? So then if t equals 0 is 2004, so then we would have the ordered pair. That's not right. So at this present stage, it sold for 56,437,000, right? So we had this ordered pair. But then if we go back to the 50s, this is what, 2004? So 54 years earlier. So if t is a negative 54, then it sold for 25,000. Okay, so we're just kind of working backwards, right? And like, I know they use a different formula where they kind of switch some things around. To me, this is more simple. I just got to think about the way that they're doing it. Okay. So we're asked to find the rate. So we have the initial amount, and we could have even made 1950 be t0, and then going forward, that might be a little bit easier actually. Let me do that instead, because part of me feels like that'll be easier. So we're gonna let 0 be in 50. Instead of t equals 0 corresponding to 2004, I'm going to have that correspond to 1950. So then I think we said 54 years later, so after 54 years, it was worth 56 million. Okay. So then our C could be, let me think about it. So when t was 0, C should be, so if t is 0, then C is going to be the 25,000, right? I'm just going to go with this and see what happens. Okay. So then it looks like we can get a function v of t equals 25, 1, 2, 3 times e to the, now we still don't have k, e to the kt, right? So we can still solve for k. So we found something for c based on our setup. So now to find k, we use the other point, right? So then when t is 54, so then the answer we get is 56,437,007. Let me clean up those numbers. That's not right either. 437,000. That's going to be equal to the 25,000 times e. We don't know k, but the t at that take is going to be what, 54k, right? So basically 54 years later. So now to solve for k, divide both sides by 25,000. So basically it's going to be the 56,437 over 25 equals e to the 54k. Take the natural log on both sides. We get 54k equals the natural log of this 56,437 over 25, okay? And then ultimately k, the rate, is going to be natural log 56,437 over 25, and then all of that over 54, right? That should give us our rate. It should be a positive number because it's been growing. I'm going to leave it like that for now. Let me see, because I know we're kind of running out of time. I always choose like the hardest questions at the very last minute. Let's see. Let me hop over to Pearson because I know we have a lot more that we need to do, and we're almost out of time. V of t. Round to 3 decimal places is needed. So let me find that rate, and let me see if we can at least get this one right. I don't know if I'm gonna be able to do the rest of them. Okay, so if I crunch this number, we would say the natural log, that's e. I need natural log. Natural log of the 56,437 divided by 25, okay, and then all of that divided by 54. So the rate I get is 143. Okay. So then the function, if we got our k, then our v of t looks like it's going to be 25,000. We're going to try it. 1, 2, 3. It might be off because of the way we set it up. E to the power of our k was 0.143 t. All right. So let's see, and we can do a quick check before we submit it. It might mark it wrong. I'm just gonna go with it though. Okay, because I know we're out of time and I didn't really have time to check it. Let's see, can we answer the question? The predicted value of the painting in 2023. 2023, how many years has that been? So again, we let 1950 be year 0. So 50 plus 23 is 73. So then we basically let t be 73 in our formula. So in my graphing calculator, for the sake of time, I'm going to go to my y equals, put in 25, 1, 2, 3, e to the power of 0.143x, okay? And then I'm going to just use this function. I know you can't see it. I'm just trying to get you guys out of here. Variables, because I think it's quick. So now we said, what year did they say? 2023. I'm just going to do 2023 minus 1950. So that way it'll just naturally give us the difference. Man, round to the nearest million. 1, 2, 3, 1, 2, 3. 854 million. Man. 854. 1, 2, 3. 1, 2, 3. Okay, let me see my time. Estimate the rate of change of the painting in 2023. So then I think what we did before, we said that answer times our k. So I'm going to say that times, what was it? 0.0143? 0.143? Okay. Round to the nearest million. 1, 2, 3, 1, 2, 3, 122 million. 122, 1, 2, 3, 1, 2, 3. And the units per year, dollars per year. All right, the rate of growth. 122 millions, it's growing by that much every year. Man, I'm not doing the right thing with my life. I need to get into art, get paid millions of dollars, and just act aloof. You just gotta give an ambiance. You just gotta sell it, right? You just gotta have an ambiance. Okay, guys. So I kept you a little bit past the time that I wanted to keep you, but we're gonna go ahead and stop here. Okay. You know, okay, I'm not doing this because we're out of time. All right. The chat is what it is. Just do the best you can. Make use of the Ask My Instructor. Ask me questions during class time. That's the best time. Because the emails, I'm doing the best I can with those. Like it's just kind of a lot, right? So, but honestly, we can take time during class to answer questions. We don't have to like do anything in particular because remember we really are doing an asynchronous schedule. Okay. If there aren't any burning questions, we're gonna end the session here. And from one beautiful mind to another, enjoy the rest of your day. All right, take care, guys. See ya.